Welcome to day 3 of Advent of Code. This one is a parsing problem, so not very array friendly and a lot of messy fun. Let's get into my solution. So we have this scrambled data which came from a machine or something, and we need to interpret it. We need to find moles and the numbers in them. That's the first problem, and then we need to find each mole with numbers in it and then multiply the two numbers and add the results. So let's see how we can find all the moles. The way I did it is probably not the most efficient way, probably not the best way, but I tried it like this. So I looked for the patterns, and the pattern is mole and then a number, and I use this character just to have a placeholder, and then another number, and then it closes. And those numbers can be 1, 2, or 3 numbers. The solution said there are a maximum of 3 numbers. They can also be 2 or 1 number. So I generated all those cases. So you can have a template to match the text on. And to get all the cases, you just make a range of 3. Then you get 1, 2, and 3, and then you want every possible combination of those. You can table them with join. And if we run that, you need to do that with itself, the table with itself. If you run that, you get all the cases. So there's, actually it needs to be, you need to add 1. So you get, there's 1 number, 2 numbers, 1 number, 3 numbers, 1 number. Those are all the cases you can get. Let's deshape that so it becomes one list where we have all the possible cases of the type of numbers that are in there. And with that, we want to create this pattern. So let's make a function which goes over all the cases. And we can interpret those 2 numbers by destructuring the left and the right amounts. And we want to return mole, but then joined with this. I'm using different characters for the start and the end because then we can differentiate them later. So this character, we can, if we put those in the list, and replicate them the amount of times we need to do the left one. We get those amounts of times of that character, and then we join that with a comma. And we join that with the same for the right. I'm in the way. And then we close it. That should generate us, let's see, all the cases. Oh, I need to join this. So there you get mole with those, mole with those, mole with those, mole with those. What we need to do then is to go over the input data. Let's import the data. .chars. I'm going to use chars because we don't care about lines. Data.txt. There's the data. And we need to make a function where you give the whole string, and it goes in windows over those strings, and then checks if one of the masks is fitting. So I call that match. And what you want is the string, so the text, and the mask. Those you put in. Let's give some space to this. And first you can create the slices. That's just the windows of mask of the size of string. So we get cutouts in the data, the size of the mask. Oh, actually, it needs to be the size of the mask to the size of the string. So you cut out the string in pieces, the size of the mask, so you can match those. And then we can go over each slice. And it's actually nice to make this a list. I should show a string hi hello of size 2, and you want to look for hi, for example. So this is the mask, and I can actually just put the mask size there, so it makes sense. Now you can see we get cutouts of each possible combination you get with that size window. As you can see, the first one would match. But this creates a column, and what I'm doing here is just destructing that. So it becomes, or I'm putting each one in the list over the cells. So all the, you can see it here, all the cells get put into individual strings and they become a list. So yeah, let's also do that here. And then we, in this function now have, if we go over each part of that, we go over each chunk we get. So let's give those the names, chunk maybe. What we want to check for is check if the chunk is equal to the mask. So if you just do chunk equals mask, then what it would do is check for the actual mask. But as we saw in these masks, they all have this weird character, and those don't match character. Those don't match numbers. And we want a function which converts those characters to functions that check for numbers. So I wrote a number searching function first, which is just 1 minus 0. So what this would give you is 1 minus 0. If you give it 4, it will give you 4. If you give it 1, it'll give you not a string, but an actual number 1. And if you give it k, it'll give you a random other point. So you only want to match the characters 0, 1, 2, 3, 4, 9, and then you get actual numbers. So we need to check if that result is smaller or equal to 0 or smaller or equal to 9. That is going to check if it's a number. So what we want is a function that we give a mask, and it returns as a function which you can use to check if the data you give does match the mask. So make check, I can call it, for example, which we want to give a mask. And what we're going to return is for each character in that mask. Most of the characters are just strings, and others are these weird things. So we can check if the character in there matches this character, or it matches this character, and we need to enclose that. If it matches either of those, then we want to give back the function number. And I can reference number here with lowercase, and we're still referring to the same thing, because BQN uses uppercase and lowercase to differentiate between calling something or referencing something. So that's an interesting feature. I think not many no other language uses. So then we give back the function number, and otherwise we give back the function does this character we get, because we're getting characters here, equal the thing we're going to give to the right. So here we return this function, and here we return this function. This, if you give it a number, it checks, it gives you back if it's a number or not, a number character. And this, if you give it a character, it checks if that character is equal to the original data we gave it, if that makes sense. We need to parse in the mask. So this would generate, you can actually see that, a nice check mask. So if I do hey, hello, and maybe the weird characters, and if we show that, mask make check, this would generate this list of functions. So this is a function which checks for h, this is a function which checks for I, this one checks for a space, and all the other characters. And if I gave it that weird character, it checks for if it's a number. And that's very nice, because then we have an array of functions which we can go over on the data, on the string we have. And then if all of them are correct, then it's a match. So let's use that function we can create. So make a check mask for the current mask. What we then want to do is go over all the slices we got and call the left function. We actually need to do this in parentheses, so it gets created. call the left function, which we get in the W variable. And here the same rules apply with capitalization. If we refer if we refer to it with a lower letter, it's just a reference to the function. But if we do a capital letter, it's actually calling it. And if we give it the X, which is the current slice, because we're going over each of them, then this should call the check on the slice. This would give us back, well, we can actually show that. So let's do a match on a mask, hi, hello on the string, or actually hi, and show that. Oh yeah, I need to use chunk here because these are the slices and the chunks are the parts we get out. And this each works because the mask, the width of it, is the same size as each individual chunk. That's what the Windows did. So here you see we show each individual check. So high was the thing we checked for. And these all match, these don't, these don't. And then we show the result at the end again. And if we put a longer thing in here, then we get a longer match. We want to then check if all of those are true, so endfold. So we get back a single boolean for a match for each slice. And we're going to keep that fact that it's using the slices still to use it for positioning later. So now we have a way to match a mask on a string. And we have all these masks. We can show them again. We can actually delete this one, and we need to store the masks here. These are the masks. And we can match them, or we can match the string, which is the input, D, on the masks. But the masks is an array of masks, so we want to do this for each of those masks. And if we check that, we get a lot of windows. These are all the sliding windows which give back if the string is matched. But we don't really want to give back booleans. We want to give some useful data. So we can, in the case that we match, we can give back the mask and the chunk. So we can use that later. And if we didn't match anything, we just return a 0. Oh, it needs to be both bigger than 0 and smaller than 9. Apparently I forgot the argument there, so it didn't generate the right functions. Okay, so now we do all the matches, and what we get back is a list. My terminal is sometimes a bit weird. So you get back this whole list of the sliding windows. It's actually a list of lists of all the masks with the sliding windows. And in those is the mask and is also the slice. So there's not much use in that, but we actually cut out the information we wanted. So what we now need to do is read the two numbers which are in the chunk and then pass in that one. So we need to make a function of interpret number, get number. We can use the mask to cut out the number. So we have the chunk and the mask. We need to generate masks for both the right numbers and the left numbers. So those are in this one and this one. Actually, we can just put that in one string. Those two. If we use the mask and do an equal to that, then we generate both the numbers. So for example, if we have so there you get masks with those numbers. So those masks we can use to cut out both the numbers. We can go for each mask and take the slice and filter that with the mask. And that should already give us the numbers. Oh, I called it chunk. Oh. So you get the two numbers, 48 and 2. Those are in there. And then we want to parse those as floats. Each of those. So in the end, you get the parsed numbers. You can see for 84 and 2. Very nice. So now we have all these matches, and essentially what we want to do is remove the zeros first. First, we can flatten the array because we have a lot of we're checking multiple masks, and we want one list. So now you don't really see it. There is only one big array. Then we can just check for each thing in the array, is it not 0? And we can filter on that. So everything that's 0 and it's filled with a lot of zeros get filtered out. So we show that you only get these masks and moles. And what we now want to do is get out the numbers. So we can get number, and we use the mask and the chunk for that. And we have the mask in the right part and the chunk in the left part. So we can just fold over the thing we have. We need to fold over each of them. And bada bing, bada boom. This is a lovely trick where if you have two things in an array and you fold over them, you just give them as the left and right argument to a function. So we have all the numbers now, and the problem was to multiply, fold each of them. So same here, we go over each thing and then we do a fold over them, which is just given to the right and the left part of the function, and then sum them. That should be the answer, the first one. I can't really check, but that should be the answer. So that's solution 1. Whoa, that was a journey. Okay, solution 2 is we found out that there are also actually do commands and don't commands, and those actually count. So we need to also search for them. And that sort of changes the state of the system while reading, where the thing we read counts or doesn't count. So what we need to do for that is find another match on a do string or on a don't string, on those two masks, and we give that the data again. So this is the do's, dos, and this is the don'ts. There we already have the data. It should work. Let's check that. Oh yeah, it has this. Oh, I shouldn't use capitals. It needs to be an exact match. Okay, there we have two don'ts. There are a lot more, so it's not really working yet. Oh, I have a random character here. Okay, strange. So here you see all the matches, all the don'ts, and there's also all the do's. So we actually matched them already. And we need to combine the do's, the don'ts, and the nulls. So let's also find the nulls, but make it flat. So you don't have all these instances of each mask of each different size, but you actually combine them all in one list in the same order. So we still match over all the masks with D, and then we get all these lists back, and we actually want to make a function of flatten. But the problem is all the lists that are all the results are different sizes, because the windows, if it's wider, it ends quicker because there's less space for to make the last steps. So we want to make them all the same size, and to do that, so x is now, it will be the argument where we give all the lists, and we need to find the largest one, and we find that by finding all the lengths and sorting that down. So the biggest one comes first, and then we pick that, and that's actually already the largest length. And we can use that to take from all the lists more than it has, so that it gets filled until they're the same size. So take from each list the size of length, so for each x. So then all the lists are the same size, but what we want to do is merge them. And sometimes at a certain position there is a 0, and sometimes there's data. So we want to check, so fold over the lists, and then so you have two lists side by side each time, and then go over each element. And if the value in the left one is 0, so there's nothing there, then use the right one, otherwise use the left one. When they're both 0, then it just picks the right one, and that's fine. So that should merge all the lists, and we can use that here to flatten all the masks. Let's check that. Let's not show the other stuff. So here we have a big list, but it's one list. It's not all the lists, all the different lists anymore, and they have all the different amounts of numbers. So 2 and 3 and 3 and 3. So all the different sorts of different numbers. And then we can actually flatten them all together. So flatten mulls, do's, and don'ts. And that should actually combine all the lists. I should actually call this combine. So here we have the data of all different lists. And actually now we're just getting all these random strings and masks. And all we want is the multiplication numbers and then some sort of command to do or to don't, so to stop counting or to count them. So let's first do the get number again on each item in the numbers, in the mul lists. So we have all the numbers. But we shouldn't do get numbers on zeros, so we can just check. And we need to keep the zeros intact because we need to remember the positioning. So let's check if x, or if it's not 0, then we can do get number on that value. Otherwise, we just keep it 0. Oh, we need to do that on each of the items. So there we get all the things, but intact, and we can also multiply them already. So we have all the multiplied numbers and zeros still in the positions. And then we have the do's and the don'ts, so we combine them. We can show that again. Everything in position, but those do's and those don'ts, we can also convert to commands to make it more readable. So let's go over those and check if they're not equal to 0, which means there are something, and call this activate, otherwise 0, and call this deactivate, otherwise 0. So now you actually get a list with activates and deactivates in it. And just for cleanness, we can remove all the zeros again here. So if it matches 0, x matches 0, filter it out. Oh, that needs to be on there. Yeah, so now we have one list with all the multiplied values, all the characters, the actions that need to be taken. So we're set up for success. All we need to do is, solution 2 is to go through that list. So let's actually call this the clean list or something. Let's go over the clean list. Let's keep this consistent with a fold. So we go over the whole list, and with a fold, the left argument is the new value. So, and we can match on that. So for example, it's activate, and the other one is the current total we have. Then we, in the case of activate, we need to keep some state here. That's the only state we have, which is do or don't. It's called active, and it's active at the start, and it becomes inactive, or it becomes active when you find active, and deactivate makes it inactive. Oh yeah, and then we need to return the total again, so we keep that value. And if it's anything else, just a value, add the value to the total, but multiply it to the active first. So that means it's activated or not. And that should give us solution 2. Shabao should be the solution. That was right. And there was an intense problem to fix in BQN. And there were prettier options than this. It's quite a bit of code. But I did make it work, and I would love to learn better ways to do it. Now I just use masks and generate all the masks and check each slice of it, which is not very performant. But you can probably make like a function which you can, like a parser, which you can give the characters, and it will give back, it'll store what it has already seen and then give back if it still matches its case, something like that. I don't know. I will put this on my GitHub. I'm going to try to put some comments there. And thank you for watching this one. Day 3 of Advent of Code.